All right, welcome back um, to the next session. I will go through parts of the EclipseStore workshop. The focus is on designing the object model for a certain use case. And we'll go through the theoretical part for all new users which weren't able to join the talk before. Just as a quick recap, that EclipseStore eliminates the need for two different data models. It's a different approach for persistence. So you don't have your Java object graph, which has to be mapped to relational database tables or key value stores anymore. And the data lives in external systems. With EclipseStore, the source of truth moves to your application. Your object graph now is your database, and external services which take the binary data is just kind of a backup for the data living in your application now. So you are in full control in your application. You're working on one shared object graph for all users, all threads, which has a drawback as well, which I'll show you later. It's probably not a drawback, but a thing you have to handle. But it comes with a lot of benefits, of course. So the object graph is stored natively without conversion to a foreign tables or foreign data structure of any sort. So you only have to keep one object model. Your Java object graph, your object design is your data model now, and there's no more conversion you have to worry about. So you can design your object graph, your data without thinking persistence in the first place, and then add EclipseStore as a persistence engine and go further from there. So I guess we can handle the stuff on the left side for the next 40-45 minutes. I will show how we design a data model from ground up, how we connect the storage afterwards, how data is created, a bit of validation, how it's done, what do queries look like now in pure Java. Full text search is a topic which is asked often, but I would prefer to show the concurrency handling before we run out of time, because this is one of the most important parts when working with EclipseStore. Okay. If you like to code along or browse through the code I'm using by yourself, this is the repository I'm using. What you need is Java 11 or newer, Maven or a build tool of your choice, and you can check out the Git repo. I can copy the link to the chat so it will be easier. All right. So I have to share a different screen for that. Would be easier. Okay, yeah. All right, here we go. What do we want to do? We have following scenario. We have a company which has bookstores all over the world. Books are Books come with authors, of course, and publishers, genres, and languages. We have, of course, our shops with different employees and an inventory, how much books are stored in a certain shop, and we have our customers with their purchases, and that's what we want to model for this case. That's an overview how it's done in the end. I hope it is readable. Chat over here. Okay, so we have books which contain different data like the ISBN, authors and publishers, genres and languages. Then there we have an address model which contains a city, which contains a state, which contains a country, and the address is reused in different entities like the shop, and the employee, of course, has addresses. And oh, that's not what I wanted. Here we go. So right, we have our books. We have our shops with their employees, an inventory which contains how much books are stored in the shop's store, and the customer and the purchases of this customer. So if you would design this application with a relational database, that's the types you would have as a table. Like you have a table book where all the books are stored. You have a table author, publisher, shop customer, and so on. And it's all handled in a flat data. So what we can do when we design our object model, we can put segmentation into it beforehand. So we have a more elegant access path in our application, and we can add related data to each other. So for example, the inventory lives inside the shop and not as a standalone entity somewhere, but it's only reachable over the shop because an inventory belongs to a certain shop, of course. And we don't have one root object with a lot of flat lists anymore, but we have some collections which are segmented into different use cases. I can show you best the code. So we have one root object. That's where all the data is reachable from the entry point for the storage manager to access all the persistent data. And from there, we can do a bit of segmentation as well. So we don't keep only flat lists with books, shops, customers, and so on in the root, but we can design it a bit more elegantly. And these subtypes or this segment types also function as kind of a data access layer to the underlying data. So if you look at the books, let's start with a more simple one. In the shops, for example, it's just a wrapper around the list. That's a very easy way to keep a collection of data, just a simple list where all the shops are put into. And for most use cases where you don't have too many data, let's say a really huge bookstore or bookstore chain has max a few thousand shops around the world. So this data can live in the RAM all the time. So don't worry about lazy loading. Just let it sit in a RAM. You'll access it all the time anyway. Put it in a list, and you're good to go. If let's say we want to manage our customers, The customers have a customer ID, which is it's not a technical ID, not a ID for a database. It's just a customer number, which we are using for invoicing and so on. So we need the data as an ID. So what we can do is we put the customers in a map with the customer's ID as a key, and there we can have a direct lookup for certain customers, and that's one of the aspects you should have in mind at the object model design. We want a short lookup path through our data model if we want to call, if we want to retrieve a certain object, and the customer is accessed most of the time with the customer ID, so we can make a map. We have a direct access or just a few simple hash lookups, and then we can retrieve the right customer. We can hide this, of course, behind a method, customer of ID, and the caller doesn't have to worry how the customers are managed internally. The caller just says, I want a customer for a certain ID or customer number, and we hide the implementation detail in the model. Yeah, sorry, I forgot to mention the project is managed in different branches, and currently I'm on the branch 1 data model, and for every feature we add, we just switch to different branches. Sorry for that. Okay, so we see we have simple ways to just hold a series of data or collections of data, just a simple list, or for a faster lookup, we can use hash maps. So what about if our lookup should be possible of a different path? Let's look at the books. In the books, all the books are kept, and we see that's one way to do it. We have multiple maps holding references to all the books for a faster lookup. Let's say we want to get all books for a certain publisher, all books for a certain genre. We can just access the map and get the list of all the books containing or belonging to the certain genre. That's one way to do it. The other way would be to add a list to the genre itself with books. But the drawback is if you add a lot of lists to different entities, you have not a central point of control. So if you have multiple collections in a single type, this type controls all the lookup path, and you don't forget to add or remove books. If you add on your book, you don't forget to add it to all the lists, because you have it in a single place. Though this is a preferred way to do it, and don't worry, the books are not copied into the different collections. These are just more references to the same book instances. So you only have a few bytes more data living in your RAM or in your storage. The book instances are not copied anywhere. So this is a possibility to design a really quick lookup to certain objects. If you're fine with the performance, let's say you only have a few thousand or tens of thousands of objects, like in a shops, just put it in a list and query the shop you want to load with Java streams, for example. It's quick enough. Only if you have, let's say, hundreds of thousands or millions of objects, I would start to put the objects in multiple collections to have a faster lookup, or you can pre-filter the lookup and put lazy around the lists, and then load the lists on demand. The lazy loading is done in the purchases. I can show you this later on. But that's one way to think about how do I get to a certain customer. In a database, you just say select customer where ID is 5, and you get a single customer back. So here we always have to start at the root. We just say in the root we want to go to our customers, and in the customers we say I want the customer of ID. That's what we that's a path you have to think. Always start at the root. How do I get to the data I need? Create a quick path to data you need more frequently, and provide lookup collections for this data, which is queried often, because we often have a lookup which publisher has which books, or which books are in a certain genre. Though that's one way to do it. But don't use it as a for every single collection or every single collection of entities. Just if you really need a quick lookup path, and if you have a lot of data, if it's in a tens of thousands or thousands, a simple list is enough. All right, 2 questions. I think I'll take the questions on the fly, so we don't forget it. Can MicroStream handle primitive collections efficiently, meaning that the primitives in the list are really stored as primitives and wrapped like implementation by Eclipse collections? Yeah, depends on the collection's internals. If your collection has a primitive array inside, EclipseStore will only write the primitives. If your collection has the wrapper types internally, it's not efficient. So you would have to use a custom type handler for that, to break it down to primitives again. But if the collection is designed efficiently using primitives internally, EclipseStore will mirror this in the binary layer, so using an efficient single stream of primitive data. How are books deleted managed in the map? Yeah, the deletion of objects is done by removing references to it. So if you delete a book, for example, you have to remove it of every collection, of course. Then the book will be removed. If you have to keep, let's say, the data for legal reasons, I would operate with this deletion flags. So put a Boolean flag into your entity and just set it to true, like delete it true, and filter it for in your queries or in your lookups. Yeah. Okay. If you use an int for the ID, it can be UUID as well. If so, what will happen to the hash map? Yeah. It's a good question. Good question. You can use whatever type you want to use for your ID. You can use an UUID, a string, integer, whatever you like. Design your object model thinking pure Java first, without thinking persistence. So you can use every type you want. And the way the maps or collections work in Java is if you have objects which don't match the referential integrity, you have to override equals and hash code in these objects, and the maps will compare the objects by equals, calling equals or call hash code. That's a thing for collection or Java core programming. Has nothing to do with persistence or EclipseStore itself. It's just how the collections work. But basically, you can use every type you want as an ID. Yeah. All right. Are there management toolings like pgadmin, etc., to get overviews of the data structures and so on? Admin access. Yeah. that's a thing we get asked all the time, because your data doesn't live in a database anymore. EclipseStore isn't a management software running somewhere in the background. It's just a library running in your application. So you have two ways to access your data. The live data in your running application, of course, can be accessed through default tooling like debuggers or profiling tools. If you want to access the data living in a storage, which is just a bytes, we have a tool for that. It's a command. First of all, it's a REST interface which you can call and extract the data, and based or built on top of the REST interface, we have a web UI where you can scroll or browse through the storage data. All right. So a step further, what about lazy loading? So our bookstore chain has the purchases. It's the fourth segmented type in our root, and that's where we keep our hopefully a lot of purchases. So we segment the data again. And for our purchases, we segment it by year, meaning the key in the map is just the year, and afterwards we have lazily loaded the yearly purchases, and the yearly purchases are just a few maps again where the purchases live in the collection. Maybe it would be sufficient to just put a lazy list here with the purchases without further segments, but it's just for demo purposes to show that you can just segment further down if you got maybe time series data which come in from sensors. You can put several maps where the first key is the year, second key of the next map would be the month and the day and so on. So you have segments per day. You can segment it down to whatever part of data you need. And in our case, we just have a single entry for each year, meaning the purchases of the current year will be accessed all the time because we get new purchases in. So this will stay in memory most of the time, or all the time, basically. And all the older years, which will only be accessed for reporting or statistics purposes, will be loaded on demand and will be removed from the lazy reference manager again if it's not used anymore. So the hot data will stay in RAM because it's accessed more oftenly. The lazy reference internally has a timestamp where it memorizes the last access time, and the lazy reference manager will clean out the least used lazy references first, meaning the cold data, and the hot data stays in RAM automatically. So if you access data all the time, you need it all the time, and it will stay in RAM, and the lookup will be quick because the storage doesn't have to load the data at this point. So, like I said, it's one way to do it. The segmentation in this case, I guess, is a bit of overkill for a bookstore scenario. In the most cases, of course, simple maps will be sufficient to have a quick first lookup, a quick first segmentation. Afterwards, put a lazy loaded collection in there, and this collection can stay in RAM through the usage and will be unloaded if it's not used anymore. But if you have a really huge amount of data, where only the newest parts are used, or some smaller parts are used all the time. We advise to put more segmentation into it. For example, for dates, you could use let's say a map integer, again a map with the month, and they are mapped with the days, and time series data of some sort. So you can say map get by year, get by month, get by day, and you have a better segmentation for that, and you don't have to load too much data. So a lot of roads lead to Rome, like the saying goes. Always dependent on the use case, of course. All right, so what about connecting this stuff to the storage? What we have for now is only poachers. So you don't see any EclipseStore code yet, except the lazy references. There's no interface, no annotation, no nothing, and you don't need it. You use your poachers as they are. Don't have to put any extra data into it just to get them persisted. Just connect the root, in our case, the data class, to your storage manager, and you're good to go. For that, we can switch over to the storage branch. Okay. All right. We have our bookstore demo type. In this case, our storage manager is living in a static context. It's one way to do it. It's just the most simple approach to put in a static context. If you work with Spring Boot, for example, you can provide it as a component, or different approaches the underlying application frameworks will provide you. But for our case, we don't sit on top of any framework, so we just keep it in a static context. All right. So the storage manager itself is created here. We use the configuration builder to configure the storage. We say our data should live in data and storage. That's the storage directory. We want to use 2 channels, meaning we have 2 parallel threads running all the time, and 2 channel directories where the I/O handling will be running in parallel. So you can utilize, if you have multiple cores available on your machine, just up the channel count, and you can leverage the underlying hardware. Afterwards, we register our optimized type handlers for the JDK collections. In this case, we have handlers for JDK 8 and newer, and we have special binary handlers for JDK 17 and newer. And every time if they are coming new, if the JDK brings new collections, we'll provide specialized type handlers for that. And depending on what JDK you're running on, you just add the type handlers, and you can use the type handlers for the JDK. It doesn't mean you can't use it with JDK 17, it just says from JDK on. So JDK 8 and newer. After that, we just start our storage manager, and the root will be loaded if there's data available. We can see in our case the data folder contains data, so there is an existing storage. So our storage root should contain data. We can take a look at it if you just start a simple main. We say bookstore demo data. and we can debug here. So debug view, all right. No. Okay. The view is gone. Oh, the wrong window. Here we go. Okay, we got an exception. That's good. Okay, so we'll create the storage from scratch. I guess I have an older version lying around. Yeah, we'll do it in the next step and we'll see it. What about data creation? So let's switch to the next branch and we'll see the bookstore demo. Yeah, here we go. The code here goes like the following. The storage manager is started, and if there is no root, meaning there's no data in a storage, we'll just use a random data generator and generates some data to play around with. It's done with a library called JavaFaker, and then we can take a look at the data. Okay, so start from scratch, create a new dummy data, and there we see we have our books, our customers filled with dummy data, and this data now was created by the faker and is now living in the data directory. Here we go. And if we debug here, we will see the storage root will be set after we start the application again. And no dummy data is generated, but loaded from the storage and restored in memory. So the root is not null, so the generation is skipped, but the data is restored from the storage data. So that's how loading works. You don't have to do anything. It's loaded automatically at startup. Only the lazy loading points have to you have to call the simple getter from the lazy loading, but everything else will be available after you fire up the storage manager. And that's basically it regarding loading data. That's all you need to know. Okay, and so if you I just check which points we can cover. I think data creation is good. Validation we can skip. Yeah, what about querying data? So if you're querying a database, of course, you will use a query language for that. We don't have that in Java. Basically, think Java core again. Don't think EclipseStore doesn't bring any query API at all. It doesn't need it. You query the objects which are in your live object graph in your RAM, and you can use the API you're used to. I guess most of the time it will be Java streams. So you can filter, effectively group, and aggregate your data, like with different databases. And you can use parallel streams to get a better performance out of it. And I guess the Java streams is what you will use most of the time if you're filtering on collections and so on. Let's say if you look in our books, as an example, yeah, we'll work with a lot of stream stuff, so and functional programming, of course. This code here, what does it do? We don't want to give the mutable collections we are using inside our books to the outside caller, because if the caller manipulates our collections, we don't know it. So what we do, we provide an internal iteration. The caller can say he wants to compute all books by a certain genre. He hands over the genre and a function which handles a stream and returns a value. The iteration on this collection here, genre to books, is done internally, and only the value which the function generates is returned. So the caller has no chance to manipulate the internal data structures. We don't expose them to the caller. And that's a very important thing to know, because we have to handle the concurrency stuff. And that's shown in the next step. Oh. Yeah, because we are operating now on a shared object graph. A lot of threads or requests will operate on the same object instances, so we have to handle the concurrency. You can do it with the low-level Java stuff like synchronized, but if you synchronize every single method you're traversing your object graph or manipulating your object graph, your application becomes effectively single-threaded. So we use most of the time reentrant locks. Reentrant locks differentiates between read and write locks. So the read operations can run in parallel, and only the write locks lock hard and wait until all reads are done, and then follow-up reads wait until the write is done. So you can keep a consistent data model. And we've hidden the reentrant lock stuff in the utility class. In this example, you can utilize it for application as well. It just has a reentrant read-write lock internally, and you just call the read and write methods and run an operation, and the utility type will handle lock and unlock in the end eventually. So your business code doesn't get too cluttered. You just put a simple read or write, depending on a use case, around your code, and the locking is done internally. That's a bit unusual for the most of you, I guess, but we're working on a better solution. In a prototype of our new Spring Boot integration, for example, we used aspect-oriented stuff, where you just put a read or write annotation over the method, and the locking is done with aspects, and so your code gets better readable, and you don't have to pollute your code with too much technical stuff. That's part of the stuff which is coming up in the future. I will show it at my talk at 2 o'clock, I think. That's part of what we are working on, so that you only have to say this method is reading or this method writes somewhere into the object graph. Just put a @write over the method, and that's all you need to do then for concurrency handling. And I guess this is the most convenient way to do this. Okay, one more question here. What about full text search? Yeah, there's no hack. You have to use a search engine, for example, Lucene. So it's part of this demo as well. It's shown in the full text branch. You can check it out. We utilize Lucene internally. I guess it's in this branch as well. Yeah, we have an index. This index type hides all the Lucene stuff. You can just use this index class and create a full text index like in the books. It is used. Where is it used? Yeah. So basically, all you have to do is you have to map the approaches into a Lucene document. So you populate your fields, and it can be used to search by with full text or with Lucene API in our case, and that's how you can achieve a full text search. Again, it's only needed if you have really huge amounts of data. If you search about a few thousands or thousands of entities, you can do just simple string comparisons in Java as well, and achieve full text search. A simple full text search for this use cases. If you want to use a more sophisticated query language like Lucene does, we advise to use Lucene. It integrates nicely, and it's used in all the other tools like Solr. So it's battle tested and can be used inside your application, can be hidden from the caller again. Just put it inside your types and use it internally, so the caller doesn't even recognize Lucene is used. Yeah. So I see we're running out of time again. It's a bit, but we could cover in this short amount of time. Just think, design your object model regarding your use case without thinking persistence first. Only think about a lookup path for your objects. How should I organize my collections? How can I pre-segment with maps where I put useful keys and only load the segment I need, and then I use Java streams or any API you want to use to query your objects further, and that's the most performant way to design or to get the most performance at runtime, just to preload, pre-segment that data. Then the data which is used all the time stays in memory anyway, because it's the hot data. The lazy reference manager will not clear this stuff out, and so you get the hot data staying in memory all the time, and that's where you get the most performance in your application. I see. Yeah. In the last branch, there's an hook for the cluster storage manager. That's done in the next talk by Christian. He will talk about the cluster and the enterprise features, where you can do the replication. I guess that's the best place to ask the questions about the enterprise stuff there. Yeah. All right. So okay, like I said, we have some cool new features coming up, like the concurrency handling enhancements. I will show you at my next talk at 2 p.m. I guess. Yeah. What's cooking, what stuff will come in the next releases, and there will I think it will take about half an hour, and so we have a bit more time left for Q&A. And if you have questions left, just contact us over GitHub discussions is a good place, or we are monitoring Stack Overflow for questions. So you can reach us very easily about these channels. I hope I could show you a bit how to get started. Feel free to use this code, scroll through it, debug around, get a feeling how MicroStream works. And that's a good place to start. Look how other guys do it. That's how I learn stuff. On the other hand, you could read the documentation and fiddle around by yourself. Everybody likes to do it differently, but I think looking at the existing code and have stuff you can debug into and look what happens actually at runtime, it's a good place to start. And the demo I showed you, the demo repository is a smaller version of our big bookstore demo. It's currently at the MicroStream repository at GitHub. And this bookstore demo brings an user interface and integration with GraphQL. The Lucene stuff is in there and a lot more. So you can see how different frameworks integrate very easily with MicroStream or EclipseStore. All right. Thanks for joining. And if you got more questions, I'll be there in my next talk, or like I said, on the mentioned online channels, we're reachable.